Rationalizing denominators is one of the more difficult concepts that you're going to encounter in this unit. Make sure you understand how I find what you must multiply both numerator and denominator by in order to create a perfect power in the denominator. Many students tell me that you simply multiply by the denominator. That's not correct. It doesn't work. If you finish the tape up to this point thinking that all you have to do is to multiply both numerator and denominator by the denominator, you're wrong. Go back and look at the examples. It doesn't work at all. Now I'm going to give you some exercises to see whether you understand the concept. Simplify. 72 divided by the cube root of 9xy squared. 72 divided by the cube root of 9xy squared. The second one, 8 times the square root of 7y divided by 2 times the square root of 3x. Copy down the two problems, work the problems, and then we'll copy down the two problems, start the tape, stop the tape, work the problems, and then restart the tape to compare answers. Here come your answers. The answer to the first one is 24 times the cube root of 3x squared y divided by xy. The second one, 4 times the square root of 21xy divided by 3x. If you disagree with either answer, be sure to check with someone. Now I want to introduce a new term. The square root of x plus the square root of y and the square root of x minus the square root of y are conjugates. Conjugates have a special property. Now notice with conjugates they are identical except that the signs are different. We have the plus and the minus. That's the difference in conjugates. Conjugates have a special property. Let's notice what happens when you multiply the conjugates together. Let's multiply the square root of x plus the square root of y times the square root of x minus the square root of y. Using the FOIL method, I get the square root of x squared when I multiply the first, the square root, a negative square root of xy when I multiply the outside, a positive square root of xy when I multiply the inside, and a negative square root of y squared when I multiply the last. Notice what happens. These two middle terms will cancel. The conjugates made it happen. Notice you've got the minus sign and the plus sign. It makes it happen. So then I'm left without a radical because the square root of x squared is x, the square root of y squared is y. So by multiplying by a conjugate, one can eliminate the radical. Of course, it's only legal to multiply by conjugate if you multiply both numerator and denominator by the same thing. Let's look at simplifying now. Let's simplify 4 divided by 2 minus the square root of 3. What we can do to simplify is to multiply by the conjugate. One can use the conjugate to rationalize two-term denominators. One can always use the conjugate to rationalize two-term denominators. So I'm going to multiply by the conjugate 4 over 2 minus the square root of 3 times 2 plus the square root of 3 over 2 plus the square root of 3. So I've multiplied both numerator and denominator by the conjugate. I'm going to use the distributive property to multiply the numerators now. I'm going to multiply the 4 times the 2, which would be 8, plus I'm going to multiply 4 times the square root of 3, which would be 4 times the square root of 3. I'm going to use the FOIL method to multiply the denominators. The first, 2 times 2 is 4. Outside, 2 times the square root of 3. Inside, a negative 2 times the square root of 3. And last, which would be a negative, square root of 9. Negative times positive is negative. Square root of 3 times square root of 3 is square root of 9. So I'm left with 8 plus 4 times the square root of 3 over 4 minus 3. 2 times the square root of 3 minus 2 times the square root of 3 gives 0. I can combine them because the radicals are alike. And then I'll have the 4 minus the square root of 9. The square root of 9 is 3. So I have 4 minus 3. Or my answer is going to be 8 plus 4 times the square root of 3 over 1. Or just 8 plus 4 times the square root of 3. Let's look at another example. Let's simplify 2 times the square root of 3 minus 1 over the square root of 3 plus 4. Okay, 1 multiplies both numerator and denominator by the conjugate. So I'd have 2 times the square root of 3 minus 1 over square root of 3 plus 4. Now that's the conjugate of the denominator because the denominator is what I'm trying to rationalize. The conjugate of the denominator would be the square root of 3 minus 4. Notice the same except I switch the signs. And I've got to multiply the numerator by the same thing. I'm going to use the FOIL method to multiply both numerator and denominator. Okay, the numerators first. Multiplying the first, that would be 2 times the square root of 9. 2 times the square root of 3 times the square root of 3 would be 2 times the square root of 9. Outside would be a negative 8 times the square root of 3. Inside is a negative 1 times the square root of 3. And the last would be a positive 4. I'm going to also use the FOIL method to multiply the denominators. The first, square root of 3 times the square root of 3 is the square root of 9. Outside would be a minus 4 times the square root of 3. Inside would be a positive 4 times the square root of 3. And the last would be a minus 16. Square root of 9 is 3. And 2 times 3 is 6. And I'm going to combine the like terms. Minus 9 times the square root of 3. A negative 8 and a negative 1 is negative 9. Plus 4 over. Square root of 9 is 3. A negative 4 times the square root of 3 plus 4 times the square root of 3 gives 0. So I'm left with 3 minus 16. I can combine these like terms. 6 plus 4 would be 10, so 10 minus 9 times the square root of 3 over a negative 13. The best way of writing your answer is to do the division, so it would be a negative 10 thirteenths. Positive divided by negative is negative. Plus, because a negative divided by negative is positive, 9 thirteenths times the square root of 3.